Hi everyone, so welcome back to the GSE virtual conference. You're tuned in to the security stream, and it gives me great pleasure to welcome back Mark Nelson from the IBM RACF development team. So hi Mark, calling live from Poughkeepsie in upstate New York. So Mark will introduce himself at the moment. So Mark's going to take us through a RACF update. And for the purpose of feedback, I see Mark's been really good and used the template, so he's got his QR code there and put the session code in. So this is session code 7E. On the note of feedback, just something that I probably should have told you at the beginning of the day, but if you're a regular to GSE, you should know this by now. But the answer to the first question, the best answer to give is 5. And subsequent questions as well, like for example, the best score is 9 and the lowest score is 1. But for the first question, the best score to give is 5 around the length of the presentation. So do keep that in mind when you fill that in. And on that note, Mark, I'm going to hand over to you. Welcome back.
Great to be back. Wish it was in person. Good afternoon, everybody. Thank you for inviting me. Mark Nelson, RACF development team. I've 35 years in RACF, 40 at IBM. Yeah, it's been a great run. I'm enjoying the heck out of it. I am here in Poughkeepsie. That is actually a little bit of an elevated photo of my site. The little blue arrow is pointing to exactly where I am right now, building 707, just a little bit off the Hudson River. Really is a lovely place to be. So lovely, in fact, that the President of the United States decided he was going to visit us last October. He happened to choose a date that was my 40th service anniversary, and I had planned a picnic along the Hudson River. I did have to reschedule it, but as a reward, I believe, I was invited to see the president speak. So lo and behold, that's me on the live video feed with the little, one of my colleagues snapped this, and I asked, how did you know it was me? And they said, it's easy. It's that Charlie Brown head of yours. I should be insulted, but I'm not. Everyone should get a chance to hear their political leader speak at least once in person. It's no matter what you believe of the politics, it's an honor that he came to visit Poughkeepsie. So what are we going to be talking about? This is a RACF update for ZOS V2R5. We've got 6 items I'll be talking about that are in the base, and then we've got some post V2R5 stuff that we'll be talking about as well. It is a lot of material. We will get through. We're going to go quickly. Do I want questions? The answer is absolutely positively yes. But since I can't do this now, which is give you all chocolate for asking intelligent questions, I promise that if you ask a question, or just remind me you're at the session, I will buy you a beer once we get in person in November. So let's start talking about the health checks that we have introduced. ZOS V2R5 is introducing 5 new health checks. One is going to verify that all data sets are protected, and by that I mean it's going to verify that you have protect all fail set. And if you don't, it will raise an exception. A second new health check will ensure that residual information is erased when data sets are deleted or space is released on the data set. That's seturops erase all. And if you make sure you have it, and if you don't, the health check will raise an exception. The third will verify that all pass ticket keys are encrypted and stored in ICSF. We're going to talk about pass tickets in a few moments, but the concept of a pass ticket is it is a password substitute that is generated. Security administrators have to set up a shared key between the generator and the evaluator. That shared DES key it should be an ICSF. We give you an option to put in the RACF database. We strongly recommend putting in ICSF. And if you have any in the RACF database, this health check will tell you, hey, you've got a pass ticket key in here. You really should move it into ICSF. The fourth of the new health checks will verify that RACF is enabled for sysplex communications. When you're enabled for sysplex communications in a sysplex, RACF will route certain actions to other systems which are sharing the RACF data set. This gives us two more benefits. The first benefit is if you do certain RACF commands like a seturops rack list refresh, you don't have to issue it on every system sharing the RACF database. You do it on the one, RACF propagates it, and the other systems will execute the seturops RACF rack list refresh. The second advantage is if something is happening that requires RACF to purge something from its internal caches. RACF has a couple of different mechanisms for caching, but in particular, when you take an action against a profile against a particular user, if you're using sysplex communications, we can signal the other caches to remove only that user's information absent of sysplex communications, they have to purge the entire RACF cache. So there's a performance advantage as well as an administrative advantage to sysplex communications. And the last one is a health check that makes sure you've enabled the RACF address space, that you've started the RACF address space. RACF doesn't need the RACF address space for the most part, right? All the RACF request equals auth and fast auth authorization checking, logging, all that kind of stuff, logon processing occurs in the originator's address space. But the RACF address space is very useful for a couple of things. First one is RACF remote sharing. But even if you don't use it for RACF remote sharing, if you have the RACF space active, you can issue RACF commands from the MVS console or ZOS console. That's very, very useful if, for example, somebody has made a security profile change that means that TSO no longer starts up, or VTAM no longer starts up, or IP no longer starts up, COM server. Right? If you have had that situation, you've configured the RACF address space, you can instantiate, you can start that recovery from that ZOS console, you log on, do your RACF commands. All of these checks run every 24 hours. And if you don't think that a particular check is applicable to you, so for example, if you're a monoplex, you don't have multiple systems, you really don't need sysplex communications, you can just disable the check in FarmLive. HCS PRM XX, just disable the check. I encourage you to put in a reason why you disabled it, and life is good. Examples of all the check output are at the end of the handout for this session. Let's change gears a little bit. Let's talk a little bit about pass tickets. So what is this thing called a pass ticket? A pass ticket, mentioned it earlier. It's some people call it an authentication token. I call it a password substitute. If you generated a pass ticket, you can supply it to whatever resource manager you're using. Could be a TSO logon screen, could be a RAC route request equals verify, an IDAC, doesn't matter. Right? The pass ticket will be accepted if it's valid, just as if it had been a password. Right? This is very, very nice because any place you could specify a password, you can stick in a pass ticket. I think my favorite one is actually create a little sample, some play code that actually stuck it in a password equals in JCL. Yeah, absolutely work. Any place a password can be used, a pass ticket can be used. Now, how do you create these things? Well, in order to create them, the originator and the verifier have to have a shared secret. We call that the pass ticket key. And you call the pass ticket generation algorithm and give it some information, like what user ID you want to create it for, what application name you want to create it for. It takes into account the time of day and generates this pass ticket thing, which when presented on the recipient side will be validated, again, based on the user ID and the application name. And if it's a good pass ticket, yay, life is good. Who uses this? Well, we originally designed it for session managers, things like the Express Logon facility, but it turns out that it's used in a lot of other places. For example, sometimes an application simply wants to pass on an identity from one address space to another address space. Well, there are some application environments who do exactly that. One other thing about pass tickets is you don't have to generate them on ZOS. You can generate them on any platform as long as you, A, have the algorithm, which is documented in RACF macros and interfaces, and most importantly, B, have that shared secret. You must have that shared secret, otherwise none of this works. And of course, C is the security administrator has set up the recipient environment to allow the receipt, right, and the honoring of pass tickets. All of this stuff is documented in the Security Administrator's Guide, in the chapter called Using Pass Tickets, and in RACF macros and interfaces. Now, how do you configure this thing to work? First thing is there's a class, the PTKT data class, which must be active and must be RAC listed. Right? The profiles you define in there must match the application name of the application for which this authentication has been requested. How do they do that? Well, on the RAC route request equals verify and in IDAC and services like that, there is the opportunity for an application to say, hey, this person is logging on to this application. It's TSO, it's whatever it might be. And it's a 1 to 8 character application name. And that's going to be key to determining exactly which pass ticket profile is going to be used. And of course, that means which pass ticket key, shared secret, will be used. If you don't specify, if the resource manager hasn't specified an ample equals, then there are some rules for defaulting that, and we document them in the Security Administrator's Guide. So there's the way you define it. You do an R define or an R alter command. There's an S sign-on segment with things like, all right, what should this key be? And you could say key mask and put in the key value. Or you could say key encrypted key value, and that's the much better one. If you do that, RACF will take your information, create a entry in ICSF, and it will be managed in ICSF in the CKDS. But there is a new option called encrypt key, which if you have a masked key and you want to make it an ICSF-based key, you can do that by simply doing the R define, or excuse me, R alter for that particular profile and specify encrypt key. And if you want to assign a key label to it, which you really should, this will give you opportunity to assign the key label that you want selected for that particular key that is being loaded into ICSF. All right, V2R4 is where we introduced this moving from key mask to key encrypted. And one of the techniques we talk about is if you want to just do this unilaterally, what you can do, assuming you have a bunch of these pass ticket keys, is do a search class PTK key data. All right, that will show you all of the profiles to which you have at least read authority in the PTKT data class. And then the CList operand, and there was a session this morning, sorry, a little early for me, talking about the power of the search command. And I'm sure this is one of the things that's right up there in terms of the powerful things you can do. You can use a search command to create commands, to create a TSO CList, a command list of commands. And what we're going to do here is to create a CList, a set of commands that will start with RALTER space PTKT data space, and then we'll insert the search command will insert the actual profile name, and then appending to that the keywords S sign on open paren encrypt key, and that will cause a migration. Once you execute that CList, it'll cause the migration from RACF to ICSF. Now, what that does is it creates a CList. The search command creates a CList of the form userid.exec.racf.clist, and then it says just run this exec. I never run anything that's generated for you before reviewing it. Take a look at it, make sure you got it right. My biggest mistake is I forget to put the space in the first operand of the CList data set, and then it's not a valid for me. Anyway, migrating from key mask to key encrypted. What's new in ZOS V2R5 is the concept of enhanced pass tickets. An enhanced pass ticket is just the same as a pass ticket in concept. It's a password substitute. You can specify it any place that you could specify a password, but it's got some additional features in it that are, well, kind of useful. And the enhancements are moving from a DES-based theme to something a little bit more modern, shall we say. So it's HMAC and SHA-512. We give you the opportunity for an expanded character set for the pass ticket that's generated, and that specifically means will it be mixed case or just uppercase. Pass tickets, non-enhanced, regular pass tickets are always uppercase values, but if you have an environment where you are supporting mixed case passwords, you can generate mixed case pass tickets, right? Got to make sure you have that. The third thing is pass tickets in the original one had a 10-minute validity period. 10 minutes either side of the time of their creation. Now we give you a validity, a configurable one to 10 minutes. But if you want to make it something shorter, let's say it's an application to application, one address space to another address space, and 10 minutes is way too long, you can make it 30 seconds if you wanted. So how do you configure the new enhanced pass ticket support? It's done very similar to the original pass ticket support. We've just got some new keywords on the secured sign-on, or S sign-on segment. And the new words are, the first one is no legacy key. No legacy key allows you to remove a legacy pass ticket key. That's the one that would have been stored in RACF. That's the way of removing it once you've migrated, of course, over to ICSF. You specify the label of the key object as it will reside in ICSF, and that's EPT key label, and that's the key label for ICSF. You have to tell us whether this is a pass ticket that will generate mixed case value. So that's type, upper or mixed. The timeout value, a value between 1 and 600 seconds for how long that pass ticket shall be valid. And the last one, replay, says, will you allow the replay of a past ticket? In base pass tickets, the non-enhanced ones, you put that in the Apple data value. And it was kind of an add-on to the design a little bit after we came out with original pass tickets. For this one, the guys who developed this decided, why don't we just make it a real keyword, its own standalone? So instead of putting something in Apple data for enhanced pass tickets, you say replay yes or replay no. And the reason for replay, by the way, is there is a granularity of about 1 second. Right. So if you generate a pass ticket and immediately ask for another pass ticket, that was within approximately a 1 second window, really based on some timer values, you'll get the same pass ticket back. Right. So, well, the pass ticket is by default single use. And if you want to allow for that multi-use, replay yes. All right. How do you generate these things and how are they evaluated? It's pretty much exactly the same way things were done in the past. There is a pointer in the RCVT, that's the RACF communication vector table, which everybody knows you can find by going to location 10 hex in storage and then taking the address 3 echo 0 from that. And that will point you to the RACF CVT or the system, actually. There's a the other products have something similar, right? And then there are some services that you can use based on the address there. RCVT TP-Gen, that's the value you find in the RCVT, but there are some other services, our GenSec and our TicketServe. These are all used pretty much the same way as they were before. There are a couple of other things that we've done with the pass ticket, with enhanced pass tickets, which actually apply to regular pass tickets. We're giving you a little bit more diagnostic information when something goes wrong, when we can't generate or can't evaluate it. For example, if you call that RCVT-based service, we will actually give you in register 0, we'll give you a reason code telling you why something went wrong if something went wrong. There is a new evaluate extended sub-function code in our GenSec and our TicketServe, and that will return some new reason codes. So one of the rules is we never break an existing function, right? We provide compatibility. Well, if you want to take advantage of some of this new diagnostics, you'll have to invoke a very similar but different in terms of it's a new function code request type in our GenSec and our TicketServe. We also have some additional information in SMF records, which we'll get to in actually right about now. If a pass ticket is presented for evaluation and it fails, right? No profile, the key is different, doesn't matter. That will be a reason for us to log the request, and you'll get some information in the SMF record that will indicate why this request failed. In addition, you will get if you are evaluating a pass ticket and a pass ticket evaluate successfully, there'll be an SMF type 80 record, event code 32, successful initiation using a pass ticket. If you attempt to replay and replay is not allowed, well, you'll see a different event code qualifier in the SMF record. Just pointing out that there's ample information when using pass tickets, in a way more than what you get when you're using just a regular password. There is relocate section 443. There's a lot of information in that SMF type 80 relocate section that talks about the nature of the authentication request. And we've got some new information in that relocate section. SMF 81 and 82 also some additional information there with some new relocate section 67 in particular. All right. If you have an application that's using either generating or passing in a pass ticket, it should not have to be changed. It should not have to be changed. I always say should because we envision all the cases we can think of. If you have an application that requires change, you need to let us know, please. But do understand that whole type, upper or mixed, right? That you have to set based upon your knowledge of what your authentication environment is. If you're not accepting mixed case passwords, then of course don't specify that for pass tickets. If you as you're migrating to this, you can in fact define both your pass ticket and enhanced pass ticket information, and then RACF will make some decisions about which it will use for evaluation. All right, basically try one then the other. All right, we talked a little bit about the use of mixed case enhanced pass ticket values, and it's the usual definition. Mixed is uppercase A through Z, lowercase A through Z is 0 to 9, and that's pretty much it. Of course, I think folks are very knowledgeable about you can look at this value or look at the setting with setter-ops list. And if you wanted to change it, setter-ops password mixed. But just remember, you have to be able in your applications support mixed passcades. You must not fold pass tickets to uppercase. We had something like this happen when we introduced mixed case passwords. We found there were applications who were doing that when they should not have done. And your passwords must support dashes and the underscore. I apologize, those are mixed values I didn't mention. You have to specify dash and underscore in the password field. All right, let's move off that. The documentation for this, couple of links right here. This was introduced with an APAR, and it was rolled back to 2.3 and 2.4 in the approximately the 2.5 timeframe. So, all right, moving on. For those of you who like to code in C, and yeah, I get the feeling the folks on this call probably might be biased a little toward assembler. We have some C header files for the control blocks listed here. So have at it, have fun. If that's your thing, we gave you something that'll make things a little easier. Profile management with alter access. So for the longest time, we've had a requirement that says, if I have alter authority, that really gives me way, way too much administrative authority. So let's take a step back. Administrative authority, the ability to update profile, define and update profiles. We can grant it a lot of different ways. You could have the special attribute, or the group special attribute in certain cases. You could have the auditor attribute, right? It's another one. This gives you a lot of power in terms of defining options and or defining profiles in the RACF dataset. If you don't have that, if you're the owner of a profile, that gives you certain abilities to administer that profile, change the access list, for example. If you have cloth authority, right, class authority, you have the ability to define profiles in a particular class, which can change security, the security definition for environment. There are some very specific class-specific profile for Unix type of things, where if you are on the access list for that profile, or there are certain RACF ones for password operations. Those are in the facility class. But if you have the requisite authority, you can do administrative things. Or lastly, field level access, or as we call it, FLAC, that can also give you the ability to list and or modify non-base segment fields in profiles. All of these are just examples of administrative ways of getting administrative authority over profile. But there's another way. Right? There's another way. If you have alter authority to a profile that's a discrete profile, well, not only do you get alter authority, but you get administrative privileges over that profile. You get the ability to manage that profile. You get the ability to change that profile. And that's a little bit of a separation of duties issue, right? In some respects, you shouldn't have the ability to change the access rules for yourself and for others, right? If you are just a user of the data. So that's the problem we're addressing. It's been a requirement out there for quite a while. Now, how could you get alter authority? Well, you could be on the access list with alter. You can be connected to a group with alter authority. There could be an ID splat entry with alter. Please tell me you don't have that, but you might. Might have a universal access of alter. Again, please tell me you don't have that. I have seen it. Or you might have a global access table entry, which gives someone alter authority to whatever matches that global access table entry. If you have alter authority, what can you do? I can list the profile, I can copy the profile, perhaps copy the access list, right? But most importantly, I can modify or delete profiles, right? So I can use RALTER or ALT-DSD or del-DSD, delete things. I can change the access list with the permit command. I can also create conflicts by defining new profiles that are more specific. So I can create a global entry, right? And that might change things. I could do things in the member grouping class. I could do things that will subvert what's in with a privilege somebody got through cloth. There's just a lot to do that you can do. So we're giving you an option to restrict alter access from managing discrete profiles. And the way one would do this is the security administrator would define a profile in the facility class, talk about it in a moment, that will say, I no longer want alter authority to convey these administrative privileges, right? And you can make exceptions. We'll see how in a moment. So what's the value of this? Well, insider attack, we're all worried about them. You don't want somebody giving their privilege to someone else for the purpose of supporting some kind of insider attack. This is something that's very easily provable to auditors because you just look at the set of profiles that we'll talk about in a moment, right? And that'll show what folks are allowed to and not allowed to use alter authority to do something administrative. And the other thing that this is a real benefit for that we'll see, I think, over time is when anyone ever come to us and say, hey, I want to define a RACF general resource profile, it usually is. And if they have alter authority to this thing, then I'm going to let them do this highly privileged thing. And we'll always come back and say, that alter authority means all the things I just said, try to use something else. And a lot of times they'll just step it down to control authority. This control authority really means nothing specific. Control is really designed for VSAM, and that means it's data set. So for general resources, that's why you see control is they didn't want to give alter. But we no longer would have to worry about that once everybody has implemented this disabling of alter administrative access. So how do you do it? And that's the question you're really here to hear. In the facility class, define a profile that starts with ir.alter.classname. The way this works is if you have update authority to this, right? Alter access to a discrete profile continues to allow the user to manage that profile. All right. And if you don't have that, then we no longer have that ability, right? So that's the control. But a couple of things about this. The first one is if you do nothing, right? If you simply move to ZOS 2.5 and do nothing, everything behaves the way it was before. Don't define the profile and boom, nothing happens. If you define the profile, ir.alter.classname, we'll talk about a little extension of that in a moment, right? Then it will be used for that particular class. So the first control is by class. Right? The profile must start with ir.alter. Right? So if you have a facility class backstop profile, that will not come into play. That's a good thing. Yeah, that's how it works. And I inadvertently made one chart non-displayable. You can actually, and I have an example in the handout of how to go out and authorize a particular user to have the alter authority still be in place for a very particular class. So that's your control. Yes, we can use generics for the class name. All right. I'm going to pause to take a sip of water. And any questions in the chat yet, Jamie?
We do have one actually. So this question comes from Phil Allison, and he says, is RACF Health Check for Sysplex communications aware of RACF subplexes within a Sysplex?
Is the RACF Health Check for Sysplex communications aware of the Sysplex configuration? The answer is no. It's a very straightforward look at the data to DSDT, the control block where we store that information, which is based upon what you've specified during your RACF configuration that's evaluated during IPO, either PARM Lib or ICH or DSNT. So no, it is not.
Thank you, Mark.
Good question. All right, let's talk a little bit about certificate fingerprinting. I think everybody knows certificates are widely used on ZOS. Why Choi, a couple of offices down from me, is the queen of certificates. Love when she gets to talk about that because nobody knows it better than her. It's used for all kinds of things, server authentication, client authentication. You can use it for program signing even. What the challenges are when you're looking at a certificate, how do you know what a certificate really means, or is, I should say? Is there a nice, easy handle on it? Now, the geeks would say every certificate is uniquely identified by the issuer's distinguished name and subject's distinguished name and the serial number. Right? That's great, but that can be very, very long strings. Wouldn't it be nice if we had something that was a little bit more handleable, was a better external handle? Right? And by better, I mean shorter and preferably of fixed length. And it turns out that our colleagues in the world who do certificate things have created such a thing. It's called a certificate fingerprint. And if you want to see examples of certificate fingerprints, just pop into your favorite browser and go to the part where it lists the certificates that it believes or that it knows about and it will honor. And in there, you'll see something that says, certificate fingerprint, SHA-256. That's the mechanism that's used to create it, right? Or it might say SHA-1, a little bit deprecated, but either way, either of those two are a good way of saying, oh, that's what the certificate is. So if I lose this certificate somewhere else, right? If I look at the certificate there and ask for this fingerprint to be created, I should see the exact same value. And if I don't, then it's not the same certificate, or I've messed something up in the moving it from point A to point B. So the certificate fingerprint uniquely identifies a certificate. It's a hash of the certificate encoded value, the DIR encoded value. And most commonly, you'll see this as a SHA-256 hash. What we're doing, what we've done in ZOS V2R5 is the places where we display certificates like the RACD cert, database unload, and certificate SMF records. We'll now see the certificate fingerprint. PKI services, separate product. It is separate from RACF, a lot of overlap though, right? PKI services will also display that certificate fingerprint on web page certificate list in its utilities and in the SMF records that it creates. Just a couple of examples as we go through here. There's a RACD cert list, and this applies to lick chain and check cert as well. Certificate fingerprint, boom, we spit it out right there. The RACF SMF records that will contain these, the RACD cert and IDAC and our data live, those have all been updated to support a new relocate section that has the certificate fingerprint. If you're using database unload, we will emit a certificate, the certificate fingerprint as well. And here are some examples of PKI services and what it puts into its various dialogues. You can even input the certificate in as a search criteria. All right, let's move on to identity tokens. So there are lots of ways to assert identity, right? And by assert identity, I mean an application says, this is Fred. Right? And the earliest way you can do that is you pass it a user ID and a flag in the request to do authentication. And yes, you have to be authorized to do this and say cash check equals no. This is Fred. Trust me. I know what I'm doing. Right? Well, we've extended that over the years. And one of the first extensions we did years ago, probably 15 or 20, was the ability to say, I have a digital certificate which represents Fred. I pass it to you, RACF, and I want you to map it to a user ID. So the security administrator originally would have to import that certificate in RACF and then put a mapping in that says, this certificate is Fred. This certificate is Fred. A little later on, we allowed you to define rules. Certificate filtering, certificate mapping, we use sometimes slightly different in the ways of describing it, where you would say, or the end user would say, here is for this certificate authority and this subject, I want you to apply these filtering rules. And when you've applied the rules, out will come the user ID that I want assigned to this particular thread of execution. So certificate name filtering is another example of what we did. We did something called identity propagation a few years ago for a different sort of style of this thing. Well, we're introducing yet another flavor of it, and that's identity token support. The difference here, this is rather an industry standard. Yeah, digital certificates are standard too. I don't want to disparage that in any way. But there's another concept for identity propagation and identity assertion that's become rather popular over the last few years, and that's the JSON Web Token. It's identified in RFC 7519. And RACF is now supporting these in a rather limited manner, but we are supporting there. So here's what we're able to do with ZOS V2R5, right? If you are doing a RAC route request equals verify or an IDAC, you're asking RACF to create an ACE, you can ask us to return back a JSON Web Token. And then you can use that JSON Web Token. Again, you have to be authorized to both request it and to pass it back in, right? You can then use that, and when you do that, you do not have to present the authenticator the password, right? So the idea here is to give you a way to basically break the logon process up into multiple pieces and to propagate identity. Now, as always, there's a control for this that the security administrator must enable. Security administrator must enable it, and that will be defining profiles in the IDT data class. Right? If you don't do anything, you can't generate, you can't evaluate these things. You have to actually define some rules for how this is going to work, and that's done in the IDT data class. The driving force that was really forcing us to go down this path was the fact that the logon process RACF terms, we call that a rack route request equals verify. That process was not buzzword alert stateful, right? And most requests in RACF aren't stateful. You ask RACF a question, we give you the answer, and then we're done, right? We don't really remember that you asked us a question. Yeah, we cache things for performance, but for the most part, these things are atomic requests. Rack route request equals verify, the logon, the creation of an ACE. You ask RACF to do this function, rack route request equals verify for this user, Fred, here's his password, and RACF goes out, boom, creates you the ACE, sticks it where it needs to go, and you have to tell us where you want to put. And at that point, we're done, right? What happens if a user ID logs on and the password has expired? Well, what happens in that case is the request equals verify comes in with a valid password. RACF passes back that password has expired. Now it's up to the resource manager to take that password is expired, got it. Hey, give me the new password, right? And then the resource manager passes in the old password and the new password, and then RACF updates the RACF database. Right, but still, you had to pass in the old password twice, once to find out it was expired and once to be the authenticator so we could set the new password, right? That works great, and it has worked great for 20, 30, 40 years, but it has a little bit of an issue when one is looking at multi-factor authentication. In multi-factor authentication, what happens is the password gets passed in and the other value generated by the multi-factor authentication device, the PIN, gets generated, right? PINs are single use, right? MFA, a multi-factor authentication product, if you use the PIN once, it's going to reject it or it's going to change in whatever that time window is, 30 seconds, whatever it might be, right? But fundamentally, you can't use it a second time. So the rack route request equals verify comes in with the expired password of the current PIN. RACF goes back and says, oh, sorry, password is expired, right? You get the new password from the user, but they can't reuse the PIN. They have to generate it again if that's possible, right? Or allow a specification of reuse if that's even possible, right? So what the intent of this service was to allow there to be a statefulness. We get the request in with the incorrect password, we pass back of the JSON web token, and then the next request comes in and the MFA piece of the work has already been authenticated, right? So that's the big use case, but the other use case is sometimes applications want to either propagate or replay authentication. Right, just as they do with pass tickets. So this is another technology for doing that. One of the big differences, however, is that you can only generate these in a ZOS environment. Right? We will not honor one that comes from somewhere else. Right. So in that JSON web token, there's just a little geeky, techie type of stuff about what kind of information you will find in there. But the key thing there that restricts it is that issuer name being staff. That's the control. These are signed objects, so one cannot get one back, alter it the way you want, and then pass it back in. The token would not be valid at that point. It would fail the verification. All right, a little bit more close at home. Something that I think a lot of folks, security administrators, want to look at rather quickly is password phrase interval changing. Password phrase interval changing. So we've had a password interval in RACF. I should have looked this up, but it's for certainly longer than I've been in RACF, and I've been here 35 years, so a very, very long time. And that value, the password change interval, which is set in one of two places, we'll get into that in a moment, it's the maximum length in terms of days that a password will be valid, or a password phrase, right? It says that, hey, this is 30 days, 60 days, 90 days, whatever it might be. You can set a system level default with set-off's password interval and the number of days, right, between 1 and 254. But you can also specify an interval for a user, and users can set their own interval, right? And you just do that with the password command and specify interval or no interval. Now, the first thing you might say is, oh, so users can make it longer? And the answer is no. What we do is we basically take the most secure, which is the shorter of the system interval and the user specific interval, and that becomes the effective one that user will have. Right. Now, the real question is, we did all this work when the only authenticator that we had was a password. Now we have password phrases. And a lot of folks are saying, yeah, 90 days, 60 days, 254 days doesn't make sense. Our standard is something greater. And I've seen a year. 365 is the most current set of thing, the most common thing that I see. We also see some standards like NIST Special Publication 800-63B. Like, don't force people to arbitrarily change these things unless that there's some kind of evidence that something has been changed. So that's what we've done for password phrases. We have a new password phrase change interval value that can be specified. This was introduced in the service stream. It was rolled back. I just don't remember how far back we rolled it. It's a new and separate password phrase specific change interval, right? And set with the setterops command. And also, well, let's get into the details right here. So how would you specify this new value? Setterops, password, phrasint 365. The limits are 0 to 64K or 179 years, or for, or 3 lifespans, I guess it might be considered 4 lifespans actually. The default value is 0. So if you do nothing, your password phrase value is the same as your password value. To set this, you must have the RACF special attribute, all right? And that's the same as doing the setterops value as well, right? A couple of examples here. There's a setterops interval 90 phrasint 365, and you see what the messages will be. Nothing exciting there. Now, setting the user specific passphrase interval, well, the range is still the same, 0 to 64K. Default of 0 says doesn't have a password phrase interval. But who can set this value? Only someone who has special or group special authority and the ownership chain of the user profile is set appropriately. So users cannot set their own. Right, that's the administrative difference between passphrase interval and password intervals. Users cannot set their own, so we don't have to do that, shorter than processing. If you have users for whom you want it to be longer, you can do that. Let's see, there was some new information in the SMF type 80 record. It's the command related information data type 6, and that's for the phrase int keyword. And SMF 81, the RACF initialization record, will also record the passphrase interval value at the time RACF initializes. If you're using the RACF remote sharing facility, just bear in mind that unless the target systems have the APAR installed, they will not understand what phrase int means. Right? And one of the things RSF does quite nicely is when 2 RSF nodes begin a communication or instantiate a connection is a better way to say it. There's a little bit of a handshake that goes on and information is passed back and forth. And if phrasint has not been installed on the other guy in the conversation, you'll get a warning, the IRI 007I message. This is, hey, this guy has a different option than this guy has. That's just good to know. The radmin callable service will support phrasint for password and phrase commands. Database unload will unload the password, the user phrase interval. We've updated the samples. The one thing that didn't happen is a RACF password controls health check that does not look at the phrase interval value. And if you think it should, that's a perfect reason to have a request for enhancements or an RFE. And here's some just examples of the different phrase settings and things like that. All right, good place to pause. Any questions on any of that?
Couple of questions, Mark, in the chat. Steve Jose said basically, great information being shared here. Thank you, Mark.
You're welcome.
Pete Buckley, hi Pete. He says, would a certificate fingerprint in RACF be carried over if the certificate were imported to another platform?
Will the certificate be carried over when ported to another platform? The answer is I don't know. I do know that RACF does calculate this on the fly in a couple of cases. So my guess is that other platforms have done the same thing. But do me a favor, email me with that question and I'll follow up with the people who know for certain.
Okay,
I do believe it's an on the fly. Thank you. Good question.
And the next question is from Christian Karachi. Hi, Christian. He says, are the certificates encrypted in base 64?
Interesting question, because the phrase encrypted and in base 64 to me are mutually exclusive. Base 64 to me is just a way of changing the format of something so that it can be more easily transported, right? It is not encrypted, right? So the premise of the question, I'm just sort of just pointing that out. But certificates themselves are usually not encrypted. There is nothing sensitive in a certificate. The private key associated with the certificate, it does not, is not part of the certificate, right? And that's a common misunderstanding, right? The private key is not part of the certificate. There are some cases where you will transport them together, and if you do, that package must be encrypted, right? But those private keys should be held very close to the vest. Your public key, tattoo on your forehead. Private key, you keep close to your heart.
He says, right, thank you.
Good. Other questions? All right, let's move on. Support for the IBM Z Security and Compliance Center. IBM had an initiative which resulted in some announcements last May-June timeframe to allow installations to more easily validate that they are in compliance with various security standards. And from a really high level view, the way this works is someone asks the various resource managers, they'll ask KICS, they'll ask RACF, they'll ask a whole bunch of other folks, hey, give me information about the sets of rules that you have defined, right? And I will aggregate them together. I will aggregate them together across systems and across platforms, analyze that information, and display a dashboard, right? And everybody knows that everybody wants dashboards for everything, right? RACF's role in this is very simple. RACF listens for the request, right? And it comes in as a RESTful API call that is made through ZOSMF. ZOSMF makes the receives the RESTful API call, and then it taps all of the resource managers, of which RACF is one, and says, hey, give me some information about your configuration and how things are set up in the RACF environment. All of these products respond to that request by writing an SMF record, a specific SMF record. It's an extended relocate session. Remember, they no longer have to be up to 255, right? It's 256. We now support much larger ones, and the response goes back into the Z security compliance system as an SMF 1154 record. Each component has their own subtype. RACF subtype is 83. So what we're going to do is we hear the call, hey, tell me about your information, and RACF spits out 1154 subtype 83 record. If you want to process this record yourself, it's documented in macros and interfaces, right? Have at it, have some fun, right? This record, and you'll notice all of the 1154s have a very similar structure to them. RACF simply plugs into that structure. It is dissimilar from the SMF 80 records that we've all grown to know and love. Right, but there are four primary sections that we'll talk about. The first is the RACF summary section, and that's really information that came out of the setups. So it's, is IBM user revoked? Are you recording the operations of the things that special users do? Are command violations being logged? Are operations users, their activities being logged? Do you support mixed case? All the things we have listed there, right? Those are basic system settings, most of which come out of setups. The next thing is called the RACF crit section, and those are the critical RACF general resources. So it's things like bpx.superuser, and there's a whole litany of what they are, and information for each of those about the universal access. Is there an ID splat entry? Is the profile in warning mode? What are the audit and G-audit specifications? All kinds of stuff like that. That's a second class of information, or SMF record section, I think they call it in their terms. The third is the unfortunately named RACF APFL. It was called APFL because that's, the APF dataset list, kind of the one we all worry about, but there are other data sets that we worry about. We worry about the RACF dataset. We worry about system recs datasets, all kinds of stuff like that, link list datasets, PalmLive datasets. RACF APFL will have an entry for each of those data sets and all the information there, URAC ID SPLAC, warning information, logging information as well, I believe. And then the last one, RACF ACTL, is information about the authorized command table, authorized callers table, which, by the way, nobody should have any entries in. And we've been telling you that for about 35 years. And we have a health check that even rats you out if you happen to have an authorized caller table entry. Somebody might look at this and say, hey, this looks a lot like the RACF sensitive resources check. And the answer is, this is a lot like the information presented by the RACF sensitive resources check. All right, that was kind of the inspiration for what gets emitted in that SMF 1154 record. So RACF is playing the game in security and compliance. We document the records that we're creating. We have to have a zero SMF installed, and that is the trigger to get RACF to speak out these records. Move on to some people would call this a paper exercise, but it has a lot more value than that. A lot of folks have come back and said, you know, what's the set of recommendations for managing my system environment? And then somebody might say, well, look at the RACF Auditor's Guide. And my response would be, don't bother looking at the RACF Auditor's Guide. It doesn't tell you nearly enough about real world stuff. So a lot of folks will look at other sources of information like the BISA Stigs. Great resource. I'm not going to say it's not a great resource, but there's certain elements in there that people have disagreed with over the years. That's fine. And it's created by an organization that doesn't have the same amount of user input as some people would like. So the Center for Internet Security, the CIS folks, it's a community-driven, not-for-profit organization. I don't want to say they're the good guys, but their intent is to come out with a set of recommendations that people have agreed on as being sort of a baseline for a ZOS security environment. In June of last year, we introduced a RACF CIS benchmark. Right, it's got 219 recommendations across 19 domains. We've already gotten feedback about stuff people want added, so we'll be evolving this over time. If you'd like to get a copy of it, it's free. It's a good resource to point folks out when they're asking, why are you doing this? Oh, look, the CIS benchmark said I should. The link is right there. The one thing I don't like is you can't just go there and download it. You have to give it an email address, and I'm always a little suspicious of that. But it's a good source. There's a RACF benchmark, DB2 benchmark, and a whole bunch of other benchmarks in there as well. Worth checking out. RACF and VSAM, something near and dear to my heart. Spent a couple of years working on this, and it was just so much fun to do. We had a statement of direction about 2.5 years ago about 1.5 years ago, that said IBM intends to enhance pervasive encryption through RACF support for the use of an encrypted VSAM dataset as its database in specific configuration. And in base ZOS V2R5, we have a VSAM dataset as long as it adhered to the following rules. You weren't sharing it with any system. So it had to be a single system, right? You couldn't split the RACF database. It had to be SMS managed, which means, by the way, it can't be encrypted. You could not be in sysplex communications mode or in RACF data sharing mode. Right, and we have a couple of other ones. All the systems sharing the database had to be at a 2.5 level. You could not define a VSAM dataset in master JCL. And by the way, you should never do that. You can't have a backup. You don't get any buffers. It's just horrible. I once said nobody in their right mind would be doing that. And within a month and a half, somebody said, hey, I found a client who's doing that. So yeah, if you're doing master JCL, just don't. Your database has to be an application identity mapping stage 3. We introduced AIM stages 15, 16 years ago. There's some function there that we need. Actually, you need to be in stage 3. We'll just leave it at that. And your database should be free from internal errors, right? So when you go through the process of migrating to VSAM, you should run EP200, make sure it runs clean. You should run database unload and make sure that it doesn't come up with any error messages. All right, so that's the base support, all those restrictions. All those restrictions in blue have been lifted with APAR OA 62267, the PTF for which was available in June of last year. Right, so it can be shared, it can be split, it can be SMS managed, it can be encrypted, and you can be running in sysplex communications mode and or RACF data sharing mode. So big news for us. The big thing, right? Are there any changes? No. If you are writing any code that does any of the RACF programming interfaces, rack route, the low-level programming interface called the Chinty, the RACF callable services, everybody's favorite IRX util, or even trapping the output of RACF commands, nothing has changed. The RACF serialization structure has not changed. So if you've ever looked at the systems programming guide, that list of 28, I think it is, or some almost 30 end use, we still do all of them, right? We are defining ourselves as a ShareOps 3.3 data set, which in VSAM terms means, hey, resource manager, the guy who owns the data set is opening it, it's your job to do serialization, and we do. There is a new sys VSAM NQ that has a lovely effect. We talked about it a little bit on RACFL of preventing you from doing something that you never ever wanted to do, but sometimes did accidentally, which was delete your RACF data set while it was in use, right? Not a good thing to do, and you might not find out about it for quite a while. So it prevents you from deleting it, prevents you from moving it, or your data management product from moving it from one place to another. Both of those things have historically caused issues that stopped with a VSAM RACF data set. The only place I can think of that somebody might have an application dependency is if you read the RACF data set directly. You open it as a VSAM VM file, you're doing whatever you're doing. Right? If you're doing that, then you may have to make changes. It really depends upon what you're doing. Most times, that's vendors, right? And we disclosed this very early on to the vendors in April of 2020, and again in September to give us some updates. We had an ICN change notification. As far as I know, every vendor application has taken care of this. So hey, life is good. If you want more information on this, Thursday, I got a whole session on migrating to a VSAM data set. Session 7Q, I think it's approximately the same time slot. All right, a couple of new functions that one of these is very recent, disabling additional logon attempts for special users. This actually got a little bit of a discussion, I guess it was late last week, early this week on RACFL. There is an APAR that rolls down to all supported releases and then some that allows you to disable the extra prompts that occur for a RACF special user if they have exceeded the seturops password revoke value by many sequential invalid logons. So let's say my password revoke number is 5, and I try to do a special user and I'm going to log on 5 times with an incorrect password. When I get to the next one, the 6th one, what's going to happen is, and this is actually a function we added probably about 20 years ago. What happens is RACF is going to pop at the operator console, an ICH302D, I'm saying it here, but there's a message that comes out. Should you give Fred another logon attempt, reply Y or N. Right? And what happens? RACF just waits for an answer. Now, when I say RACF waits, it's really not RACF waiting. It's the thread of execution that did that rack route request equals verify that asked us to validate Fred's password. That's what it is. For resource managers that are multi-threaded, it's not an issue. For resource managers that are single-threaded, that resource manager now cannot process another logon attempt. Right? So this APAR gives you the ability to disable that additional set of logon attempts. And you do it on an application by application basis. And the way you do it, you define an X facility, not facility this time because the name's a little long, an X facility class discrete profile, so generics are not allowed, that is of the form of the name IRR.deny.special .user.additional.password.attempts.apple, and then the 1 to 8 character Apple value. We go with that name because I think you look at that profile name, you know exactly what it means, right? Deny special user additional password attempts .apple and then the application name. That does depend upon, well, the Apple name that was passed in. Right? If an Apple name wasn't passed in, then we're going to do the same thing we did with pass tickets. We're going to derive one, and we document what that value is. By the way, this is a profile existence check only, the ACL, none of that matters. Scanning and monitoring, something that's very big on a lot of folks' minds. You should be looking at your special code, and when I say special code which has additional privileges, and you should be monitoring your system for when unusual things happen. Those are 2 very generic statements that I don't think anybody could disagree with. There are a couple of products that IBM has had in the marketplace, or I just introduced one. If you're aware of this, ZACS, the authorized code scanner, has been extended Again, these are price feature things. It's extended to AC1 programs on an ATF authorized library or ZOS Unix binaries with the ATF extended bit and linked with AC authorization code 1 and ZACM authorized code monitor. And what that does is that listens for unusual things. And by that, I mean addends in code and then interrogates those, looks at the data associated with them to see, is this an indication of somebody who's doing something that they really shouldn't? The system said, no, you can't do that. But is it an indication that somebody's trying to do something? More information, APAR OA 62566. Sharing a RACF VSAM, RACF DB with VSAM. Oh my God, that's wrong. It's sharing a RACF database with ZVM. My apologies, I will fix that. So starting with ZVM 7.3 RACF, the RACF version and the ZVM version will not be able to share the RACF data set. And if you're on a ZVM 7.3 system, the IPL will fail. And if you're on a ZOS environment and you attempt to use a VSAM data set at the 7.3 level, you will be told that the IPL will stop there and say, nope, you can't use that data set. Give them another. So we're on time. Yay, 1 minute over. That's on time for me. In closing, questions? Any last questions before we go to the in closing?
Mark, there was one question from Steve Jose. He says, with the zero trust world, when will any and all access, such as read access to the RACF databases, be no longer required by RACF administrators?
So my first comment on and anything zero trust is the journey to a destination that you will never achieve. That might be a little controversial, but the journey is you must go on it, you must do your best effort, but you'll never get to that nirvana state. As we find places where administrators or end users have too much authority, we need to ratchet those down. But we also have to be cognizant that by ratcheting them down, we can't impact legitimate access to data. So Steve's question, I could be cynical and say the answer is never, right? But that doesn't mean we're not going to make it significantly better over time. So Steve, I apologize for kind of wrapping up that way, but come at me. What have I gotten wrong?
And can I add a piece to that actually?
Oh, yeah.
on the RACF side? So if you're using Z-Secure, there is no requirement for the users to basically have read access to record data. You've got the Z-Secure server that you can fire up, and it's actually the server that does the open of the RACF database, not the user themselves. So that's one way you could tackle it if you've got that product.
Sorry, I think I misheard the question. Is this question specifically about the RACF database?
Well, Steve says such as.
Yeah. Oh, such as. Okay. So let's focus on that one.
Am I unmuted?
Yes.
Great. So whether you have Z-Secure or not, there are certain utilities in RACF that do require you to have actually update access or read access to perform those RACF administrative functions. The competition, obviously, ACF2 and Top Secret, they don't require any administrator to have any access to the actual security databases. And auditors find that as a weakness, where a user could download your RACF database if they have read, or God forbid, they could update it if they're allowed to update access. My question then is, when will RACF, the utilities, any of the requirements that require those administrators to have read access or update access outside of RACF commands to perform functions?
So we got to get real specific here. What utilities are we talking about?
That is a significant risk.
It is, but we have to manage the risk and understand the risk. So if you're running a RACF utility against a RACF data set, it's going to need read authority. And let's be very specific. UT 100 does not. Database unload does not. It used to, but it doesn't anymore. That's been around for like 10 years. And I think the word about database unload in particular, and again, we changed it a while ago. And unfortunately, the way we change it is we just somewhere in a book said, you must have, instead of update, it says now you must have read, unless you're doing lock input, which makes sense because lock input says I want to write to it, right? So if that's the utility or UT 100, then the answer is we're done. Right, the other utilities, 200, which is copying and analyzing, 300, which is block update, 400, which is the reorg utility. You must have read to the thing that's coming in because that's what the utility does. None of these are administrative ones. They're systems programmers functions. Min00 is updating data set. Again, systems programmer. Trying to think the other ones offhand. I mean, for the most part, RACF administrators, security administrators shouldn't need it. And if it's database unload, then we just have to have a conversation with them saying that, yeah, you don't. Now, I know that restarting to a RACF database is pretty huge also. And the way you mitigate any of the issues or some of the issues with that is you make sure you're running KDF AES. So those offline attacks are a lot harder to do. It's still a lot of information. Give me the RACF data set. I now have your user ID and group mapping. I've got a lot of targets there to look at. Right. It's not the only way to get those though.
I totally agree with what you're saying.
Mhm.
However, when we're talking mainframe versus mid-tier, that highly hackable every 2.5 seconds, actually it's probably 1.5 now, where those mid-tier servers get hacked all the time. And the mainframes, quite frankly, well, there's one publicly hacked mainframe up in Northern Europe that RACF database was downloaded and promptly hacked because they weren't using KDF AES. And well, I'm actually the one that wrote the standard in the DISA-STIG to require KDF AES way back when many years ago. However, when we're looking at apples and oranges, we know for a fact that Microsoft and all these mid-tier servers, their security databases are quite frankly exposed. And anytime we talk about the mainframe, we need to have strong controls in place where there is no valid requirement unless you're reallocating a security database. No one should have that access full time, period.
Agreed.
And so I would challenge, is that in your new CIS standards that are published out there? If not, when will it be? And two, can we get updates to the documents that specify these out, what role should have them, and that in fact should not be permanent full-time access ever.
So we're in violent agreement over that last statement, right? So the question is, what type of processes would need authority to do this? And to me, that's the the systems storage management ones of making sure backup and recovery have been properly enabled, right? I don't know if it's in, I don't recall if it's in the CIS benchmark, and I doubt it is with that specificity. We probably make a generic statement about access must be controlled. But I do like the idea of being very specific about it, right? Especially, how bad are things in the real world? I do remember going to a session once where somebody proudly said, I unloaded the RACF database and I put it on my laptop and look at all these really cool queries I could run. And half the room's jaws hit the ground. Right?
Yeah. Well, I mean, that's what we're talking about, because ACF2 top secret security databases are locked down. Admins don't have access to it. The manuals don't even talk about they should have access to it. But RACF for years required access for them to do certain functions. That's a fact.
They do, but hold on, I'm going to reject a little bit of that premises. If these other products have databases of their own, then they must be backed up in some mechanism. Do they rely on a system function that does that?
They have their own automatic backups taking care of that, which is a different subject. And from a storage point of view, that's a different subject. That's not where security administrators have required access to do certain functions.
What security? I'm still looking for security administrators. In what cases do they need authority to the RACF data set itself, the live, primary, or backup, or offline RACF data set? Security administrators.
It all depends if what you have in your IRR RACF Security Administrators Guide states for IR UT200, DBU 00. Those types of things. It says system programmers, but that doesn't mean every shop has that. So if we're doing these types of functions, can they we need to put, I guess, in the documentation, better documentation that provides specifics and risk level. If this access is granted, this is a serious risk.
I like that. I like that.
That's not in documentation.
Doesn't a lot of that come down to your internal security policies, though, and how you determine what people are allowed to do what and how?
We we need to look at from the vendor level, because that's where auditors look at. They may look at internal security documentation, but they look for guidance from the vendors of RACF, Top Secret, and ACF2 on how best to secure this, as well as DoD STIGs, which I spent 20 years helping to develop. I get that, but we need to do better, I think, at identifying this is a real true risk, and heads up auditor or heads up compliance team ensure this is not in place. And the same for the RACF Global Access Table. In a zero trust world, I'm not sure how the Global Access Table can still exist, even though it was written or exists for performance reasons. But in this modern age with mainframes, with the capacity, SSD drives, etc., I don't see where the performance hit would be, yet the Global Access Table still exists. And it frightens me when I know historically I have found at least one customer with SysOne ParmLib in the Global Access Table.
Well, it's fine if it's fine if it's read, but I suspect you're saying it was altered, and that's horrible. I've seen sys1.sprat RACF data sets readable by the world. Yeah,
Yes,
mistakes happen.
Yes.
And by the way, that particular scenario is why we created the RACF Sensitive Resources Health Check, with the ability for you to drive for any particular user. So you'd flesh those out. But all of this is saying that, in my mind, we're looking for better guidance. Got it. The RACF Auditor's Guide is not that guidance, quite frankly.
No, it's not.
This estates are part of that guidance, and I'm curious what they say about this topic. And the CAS also should be guidance, and let's work together on making them better.
Agreed.
And one other thing I saw that IBM's added IR.alter. I would challenge you, I guess, to look at a new resource that would prevent the Global Access Table from anyone from adding entries to that. And provide some guidance on that, some more solid guidance on that. Accidents happen, but we need to be better at being proactive, not reactive.
But I do like the idea of actually providing a way to move on to the next Global Access Table, because, quite frankly, that is something that violates one of the basic tenets of zero trust. People don't use it for performance, maybe too much, certainly too much. We'll have to figure out what the control would be. You can prevent people from putting new stuff in there. Well, not security administrators, because if you have special, you can. Maybe we can do that. Maybe we have a way, like with our alter, saying if it's there, we're going to ignore it. And we'll do it on a class by class basis. We need to just think off the top of our heads. Good requirement. I look forward to the RFE.
Yep, sounds good, Mark. So I need to stop this conversation right now in its tracks, as fun as it is.
Great session.
Thank you.
We could go on all night.
That was my closing chart, by the way. You get to it, David.
So someone posted a question in the chat. Where can I find the number for this feedback? So it's 7E. So there is a link in the chat, by the way. If you click on that, that will take you directly to the feedback for Mark's session. Please do complete that. And any feedback that you haven't done throughout the day, please do it. It's really important for presenters and for GSE, and of course for those of you who are collecting CPE and CPD points. One thing I forgot to mention, Mark, I love that health checker. I've now got access to a brand new spanking ZOS 2.5 system with nothing in the RACF database, everything's switched off. And all these health check warnings are coming up, and it's just, I've been working for them. It's great. It's really moved on over the years, hasn't it?
So I got to tell you, it has. There are people who hate it. I do know some folks who've turned it off. It keeps yelling at me, and I just want to smack them because it should. Listen, when we get together in November, let's have our horror stories discussion. What did the health checker tell you that you didn't know?
Yes, I think that's a good idea. I like the sound of that. Yeah. So, Mark, thanks once again for coming to a splendid session for us. Good to see all the updates that are coming in RACF, that are in RACF now. It's great to see how the product's evolving. So this is the last security session for today, folks. But GSE, the conference still continues after this. So at 5 o'clock UK time, there is an IBM keynote. That's for an hour. So if you are interested in accelerating application modernization, then you might want to join that. Tomorrow, the security stream has a full agenda for the day again, as do other streams. So we are starting at, again, 8:30 UK time with Mark Wilson. He'll do the opening for day 2 of the conference. And then in the security stream, we start back at 9 o'clock with a session from Gideon Tudor from IBM MQ development, we're talking about controlling access to your IBM MQ system. So if you're running MQ or you're planning to, then you might want to join that. So basically, that's all from me for today. Thank you ever so much, folks, for sticking with us today. I've really enjoyed today. Lots of interesting things come out. I've made lots of notes. So I hope you enjoy your evening, whatever you decide to do, and we'll see you back here tomorrow. And Mark, thanks again. See you very
Most
soon.
welcome.
See you on Thursday.
See you Thursday and in November.
Yes. Take care, everyone.
Bye-bye.
Bye.